All right, so I'm going to go through these questions with you real quick. If after watching this you're still not sure, just make sure you email me for help then. But for number one, it says find the complementary and the supplementary angles that find the complementary and supplementary angles to the angle that measures 53 degrees. So when we're trying to find a complementary, they add to 90. So that means our complementary angle plus 53 has got to be equal to 90. So then our complementary angles, we can do 90 minus 53. So our complementary angle is then going to be equal to 37 degrees. Our supplementary angles add to 180, so we can say our supplementary angle plus 53. And we're using 53 because that's the angle that we're asked to find the supplementary and complementary to. And that's equal to 180. We subtract 53. So then our supplementary angle is equal to 127 degrees. All right, so you just have to know that complementary adds to 90, supplementary to 180. So now we're applying that information from question one and question two. It just says solve for x. If two angles are complementary and the first angle is 5x plus 15 degrees and the second one's 45, solve for x. Well, we know complementary angles add to 90 degrees. And the first one is not a specific number, but it's an expression. So 5x plus 15 is the first angle, and plus 45, which is our second angle, we know has to be equal to 90 degrees since they're complementary. So now we can combine our like terms. So 5x plus 60 is equal to 90. We'll subtract the 60 from both sides. So 5x is then equal to 30. Divide each side by 5. So x is then equal to 6. All right, so all they asked for this one was solve for x. And in this next one here, it says solve for x. Well, this is applying our angle addition postulate and also knowing that a straight line forms an angle that's 180 degrees. So I know that these two angles, 9x plus 17 plus 37, is equal to 180 degrees. It's actually kind of applying a few different things that we learned. Linear pairs, angle addition postulate, and they're also supplementary. But 9x plus 54 is equal to 180. So then we subtract 54 from both sides. So 9x is then equal to 126. And divide each side by 9. And x is then equal to 1, 4, so 14. All right, so that's solving the first three. Now, when it says name it 4 different ways, it's the first way that we can name this is, remember, we can go side of a vertex or side of our angle to our vertex and then to the other side. So we can name it angle A, B, C. And when we name it like this, it just tells us the order that we're starting and going. So A, B, C means we're starting at A, going to B, and going to C. Another way we can name this is we could just start with C. And if I start with C, it's just going in the opposite direction. So C, B, and then we're going to A. So we can also name this angle CBA. As long as if our vertex was in the middle there, which it is, it doesn't really matter which one we start with. It's just we need to go side, vertex, side. In the future, though, it is important with the way that we go some things, especially when we're talking about congruent or similar triangles. Order matters. So that's why it's important that you can see that we can name both of these angles in both ways. It means the same angle. It's just telling us where we're starting from and where we're going from, like the route that we're taking or the perspective of it. And then the other thing is, since there's only one angle here and it's not like any adjacent angles are built off of this, we can just simply name it by its vertex. So I can say angle B. However, if this had another ray over here, let's just label this D, if I just say B, well, which one are you talking about in this case? Because there's actually 3 different angles that we can be referring to. But since there's one angle here, and if I just say angle B, this is the only angle it possibly can be referring to. And then the last way that we can name this is, since I put a little 1 in there and that 1 doesn't have a degree symbol, so it's not saying 1 degrees, that's another way we can name it. We can call it angle 1 since it was named for that already. So for this next one, another name for ray AC. Well, ray AC starts with A and goes here to infinity. So if we're trying to find another name for ray AC, that means that we need to start with A as well. And now the only other point that's on here is B. So if I say ray AB, If I'm drawing this in now blue, well, I'm going through b to infinity, so you see it's incorporated, including that point C after it as well. So another name for this is ray AB. Right, so for number 6, define x. If the measure of angle LMN, so LMN, that's the whole thing, is equal to 135 degrees. LMB, that's this angle here, is negative 1 plus 45x. DMN, that's this angle here, is equal to 23x. Well, we know that the two smaller angles will add up to the larger one. So we can just use our angle addition postulate of negative 1 plus 45x plus 23x is equal to, and the whole thing added up to 135. And now we're just going to go ahead and solve. And by doing that first, we're going to combine our like terms. So we have negative 1 plus 68x is equal to 135. And then we're going to add over the 1 to both sides. So 68x is equal to 136. And then we will divide each side by 68. So x is then equal to 2. All right, number 7. So for here, it's the same thing as the other one we just did, but now it's a segment addition postulate. We know that this part of the segment added with this part of the segment must be the entire segment. So we can set it up as 17 plus 2x plus 8 is equal to x plus 18. So now I'm going to combine my like terms. So 2x plus 25 is equal to x plus 18. I'll then subtract over 25. So 2x is then equal to x minus 7. I'm going to subtract over the x. So we get x is equal to negative 7. The directions here didn't say to solve for x, so it says solve for FH. So we want to know what this entire segment is equal to. So if x is negative 7, FH was equal to x plus 18. Well, now we can substitute in that negative 7. So FH is equal to 11. Right, finding the distance. Well, here's the distance formula. So x2 minus x1 squared plus y2 minus y1 squared. And it doesn't matter which one you make, x1, y1. I'm just going to go ahead and make this one x1 and y1 and x2 and y2. I do have a little bit of a reason behind it, but it doesn't really matter. So our square root then, our x2 is equal to negative 9, so negative 9. And our formula is minus, and x1 is equal to negative 12. So that means it's minus negative 12 squared. All right, so then we're going to go ahead and do plus. Now it's y2 is 6, y1 is 2, so 6 minus 2 squared. And now we're just going to go ahead and solve. Minus and negative turns are positive, so this then becomes the square root of 3 squared plus 4 squared. 3 is 9, 4 is 16. We'll finish it over here. So this is square root of 25, which is equal to 5. So then the distance of EF is equal to 5 units. All right, so for this one, it says find the area of the square. Now, this would be an exceeding question of this topic, but we know that the square has 4 equal sides, and the area of a square is equal to just a side squared. So all I need to do is find a distance of one of these sides. So it doesn't matter which one. You can pick any of them. Just pick one of them. You don't have to even do more than one, because since squares all have the same, it's just going to be doing the same work over and over again. So I'm just going to go ahead and just pick 2 points. Here I have a point -1, -3. And here I have a point of -3, 3. Why I picked those? No reason. Maybe you might want to pick one of these two since you have more positive numbers, but it doesn't really matter. But the square root, so I'm going to say this is x1, y1, and this is x2, y2. So the square root of -3 minus -1 squared plus 3 minus -3 squared. So just make sure that when you're plugging in these numbers, you're plugging in them in with the negative, because the formula's minus doesn't take away that negative. It will actually turn into a plus. So now it's the square root of, well, -3 plus 1, so it'll be -2 squared plus 6 squared. Well, -2 squared is 4, 6 squared is 36, so it's the square root of 40, which is equal to, we don't even need to even put it as a square root of 40 or give us the value of it, because now we're going to do, well, the area is equal to the square root of 40 squared, and 40, the square root of 40 squared is 40, so our area is equal to 40 units squared. All right, so now to find a midpoint, this is another formula. Remember, you will get these formulas as well, but the midpoint is equal to, it's the average of our x's and y's, so it's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Once again, it doesn't matter which one you make, as long as you're consistent. So I'm just going to zoom out real quick. So then this just becomes, our midpoint is -2 plus -8 divided by 2, and -4 plus 12 divided by 2, which this then becomes -10 over 2, and 8 over 2, which then becomes -5 and 4. So our midpoint is -5, 4 on the corner plane. All right, now this one, we're given a midpoint, and then we're trying to find the coordinates. So we know our midpoint formula, so I'm going to do this one over here. So our midpoint is equal to the average, so x1 plus x2 over 2, and y1 plus y2 over 2. Right? In this case, we know our midpoint. Our midpoint is -1,9. So I know that this is equal to -1,9, our midpoint. And now when I go to plug in my x1 and y1, I only have an x1 and y1 to plug in. So it means I'm trying to find what my x2 and y2 is. So I'm going to go ahead and plug this in. So we have 6 plus x2 over 2, and we have 7 plus y2 over 2. So now I know that this x value is generated from this here. So that means I can set them equal to each other. That -1 is equal to 6 plus x2 over 2. And then I know that this one, 9, is equal to my y value of my midpoint formula. So I can then say that 9 is equal to 7 plus y2 over 2. And now just go ahead and solve. Well, I know that this fraction bar ultimately means division, so I need to multiply each side by 2. So -2 is equal to 6 plus that missing endpoint. And then to solve for that, we just subtract the 6. So that means that our x value of that missing endpoint has to be -8. So B, we know that our x value is -8. And to solving it the same way, we're going to multiply each side by 2. So 18 is equal to 7 plus y2. Subtract 7. 11 is equal to y2. So it's -8 and 11. And then we can check our work by actually finding the midpoint of AB and making sure it gave us the value that the midpoint that they gave us. All right, so if something is bisected, we know that they're equal. So in this case, I can set them equal to each other. 3x minus 7 is equal to 20. So we add the 7. 3x is equal to 27. Divide by 3. X is then equal to 9. It doesn't ask us to solve for anything more than that. So just solve for x. And we know whether something is bisected as an angle or as a segment. It's the same thing. They're equal. So I can set 4x minus 10 equal to 2x plus 34. So I'll subtract the 2x. I'll add over the 10. So 2x is then equal to 44. Divide by 2. X is then equal to 22. But in this case, they said find QR. So they want this entire segment. So we just need to go ahead and plug this into one of them. I'm going to plug it into here. So I can then say 4 times 22 minus 10. So 88 minus 10 is 78. So if this is 78, I know this one's also 78. So then to find QR, I can then just do 78 divided by or times 2. So QR is then equal to 156. All right, given that the triangle is a right triangle, so I'm just going to sketch this triangle, put a right angle there, find the hypotenuse, so that is this one, across from 90 degrees, if the two legs are 7 and 2 centimeters long. So now, since I have a right triangle, I know we're going to use Pythagorean theorem, so c squared is equal to a squared plus b squared. So it doesn't matter which one we put in, our a or our b, because they both represent our legs. So 7 squared plus 2 squared is equal to x squared. 49 plus 4 is equal to x squared. So 53 is equal to x squared. And then to solve for this, we will take the square root of each side. So x is then equal to 7.3 centimeters. All right, so 7.3 cm. It didn't say where to round it to. On your test, I would. So for this one, it says the bottom of the ladder must be placed 3 feet up from the wall. So this one we actually have to sketch. So here, let's just draw a wall. So here I have a building. And let's just put some grass at the bottom of the building. Okay, so here's grass. And we are now going to be placing a ladder along this wall. So here we have a ladder. I'm just going to draw, obviously this isn't the way ladders look, but just so you can just identify that there's a ladder. Now, when a building intersects with the ground, it's going to be intersecting a 90-degree angle. So it's creating this right angle. And it says if the ladder is 12 feet long, so that means I know that this is 12 feet, and it's placed 3 feet up on the wall. So here it is then going to be 3 feet. Well, the ladder must be placed 3 feet from a wall. Sorry, I didn't read this question properly. It's going to be the same answer, but I mean, it's this distance though. Sorry, 3 feet from the wall is here. So it's saying how far up the wall. So we're trying to solve then this side here. So since the building intersects at a right angle, it's giving us a right triangle. So we can use Pythagorean theorem. So our legs are x and 3. So x squared plus 3 squared is equal to our hypotenuse of 12 squared. So x squared plus 9 is equal to 144. We then subtract the 9. So x squared is equal to 135. And now we take the square root of each side. So x is then equal to and the square root of 135 is 11.6. So that means the ladder is 11.6 feet up the wall. Okay, and this is the last one. So it says solve for x. So this one, these are vertical angles because they're both created by these opposite rays. They're directly across from each other, and we know vertical angles are equal. So I can set 5x plus 20 equal to 80, and then I subtract 20 from both sides. So 5x is equal to 60 divided by 5. So x is then equal to 12. All right, that is it. If you have any other questions, just send me an email.